We begin our quadratic unit with factoring. In your photable, there is a guideline to help you factor. If you don't remember, this is a review from Algebra 1. We want to always take out the GCF first, always. If you have two terms after you take out the GCF, look and see if it's a difference of squares. If it's not, then we go over here to three terms. If it's three terms, look to see if it's a perfect square trinomial. And if it's not a perfect square trinomial, then we do target product, target sum. Factor each of the following. Remember, factors are all the numbers that multiply together to give you a number. Let's look at some examples. Factor each of the following. Well, to begin, a factor is a number or expression multiplied by a number or expression to get a product. So I begin by first taking out the GCF, the greatest common factor. So to take out the greatest common factor, we need to look at the factors of each term. In the first term, 3x squared, the factors of 3, or the numbers that multiply together to give me 3, are just 1 and 3. The variables that multiply together, the factors that will give me x squared, are just x times x. In the second term, the numbers that multiply together to give me 6 are 1 and 6 and 2 and 3. So those are all the factors that will give me 6. And the factors that give me x are x and 1. I want the greatest common factor of both of these. Well, they both have a 1 in common. And they both have a 3 in common. So 3 is the greatest common factor with the coefficients. Now let's look at the variables. They both have an x in common. That is it. There's no more in common. So I will write down x. So the greatest common factor of this expression is 3x. Now to completely factor this, I take each term and I divide it by 3x. We've pulled 3x out to the front. Because I have two terms here, I'm going to have two terms on the inside of my parentheses with an addition symbol. And we're going to divide each term by 3x squared. 3 goes into 3 one time. X goes into x squared one time. Remember, when we divide like bases, we subtract the exponents, and this is really a 1, so 2 minus 1 is 1. 3 goes into 6. For the second term, 3 goes into 6 two times, and these will just reduce to 1. So 3x squared plus 6x factors to be 3x times x plus 2. That means that when I multiply 3x times x plus 2, I will get my result, or my product, of 3x squared plus 6x. Notice that x plus 2 cannot be factored anymore. This does not go any further. Let's look at example 2. Remember from the notes above that we always want to take out the GCF first if possible. The factors of 125, 1 times 125, and 5 times 25. So these are the numbers that multiply together to give me 125. The factors of x squared are just x times x. Now let's look at 80. The factors of 80 are 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10, and that's it. Let's look at our greatest common factor. For the coefficients, they both have a 1 in common. They both have a 5 in common. And that is it. So the greatest common factor for 125 and 80 is 5. Let's look at the variables. There's not any variables in common. So the greatest common factor of 125x squared and 80 is 5. Now let's go back to our notes for just a moment. Our notes say always factor the GCF first. After that, look for two terms. So if it is a difference of squares, In other words, the a term is a perfect square and the b term is a perfect square, then we have the form a plus b times a minus b. So let's pull out our greatest common factor. I have 125x squared minus 80. Divide each term by 5. 5 goes into 125, 25x squared times, and 5 goes into 80, negative 16. I can't just stop here. Once I get to this point, I need to make sure that I can continue or not. Looking at our notes from a while ago, we always take out the GCF first. Well, we just did that, and I have two terms. So I want to make sure, second, is this a difference of squares? If you can recognize the pattern for difference of squares, it saves work. We're looking for, is this first term a perfect square, and is the second term a perfect square, and is there a difference symbol between them? Hence, difference of squares. In this case, 25 is a perfect square. The square root of 25 is 5, and the square root of x squared is x. So the a term would be 5x. And the perfect square root of 16 is 4. And there is a minus sign in between these two terms. So this satisfies the second thing to look for, which is difference of squares. 5 still stays part of the formula, but difference of squares is easy. We write down the first term, 5x, the second term, 4, and both of the parentheses. One is positive, one is minus. Now we are done. Next example. X squared plus 15x plus 36. Notice that the first thing we look for is to see if there is a GCF. Because this is a 1, and this is a 15 and 36, there is no GCF greater than 1. Does this have two terms? No. So it's not a difference of squares. We do have three terms, so we want to do target product, target sum. Remember, to get the target product, we multiply. Remember, to get the target product, we multiply the coefficient in front of x squared together and the c together. So the target product is a times c. So the a is 1, the c is 36. So 1 times 36 is 36. The target sum is the b, or the coefficient in front of x, and that would be 15. So I need to find two factors that multiply to give me 36 but add to give me 15. 1 and 36, 2 and 18, 3 and 12. I can stop right here because I noticed that 3 and 12, when I multiply those together, I get 36. But when I combine them together or add them, I get 15. So we have x squared. We're going to replace 15x with 3x and 12x plus 36. So 3x and 12x is 15x. I have not changed my problem. I've just rewritten it. Now we want to factor by grouping. Take the two first terms together, x squared plus 3x, put them in parentheses, and add the second two terms together, 12x plus 36. So the factor by grouping, the first thing we do is we replace 15x with 3x plus 12x. Group two terms together. It doesn't matter which pair I want to group together, I always group just the first two together. Make sure you put a plus sign between them and group the second pair together. To factor by grouping now, we take out the GCF of each parentheses. So the GCF in the first term is x, and what's left over, x goes in x squared x times, x goes into 3x 3 times, plus The greatest common factor in the next grouping is 12. 12 goes into 12 one time. 12 goes into 36 three times. So now that I've pulled out the greatest common factor, what's left over is my answer. You can see that x plus 3 is easily one of my answers. What's left over, x plus 12, becomes my other factor. Notice they're factors, so they are multiplied together, and this is the answer. Let's look at another example. 3x squared plus 24x plus 45. First thing we want to do is take out the GCF. Looking at all three terms, the factors of 3 are 1 times 3, and the factors of x squared are x and x. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The factors of 45 are 1 and 45, 3 and 15, 5 and 9, and that's it. So let's look at the greatest common factor of all these terms. They all three have a 1. They all three have a 3. 3 is the greatest common factor of all the numbers, or the coefficients. Now let's look at all the variables. 24x, I forgot that one has a factor of x there. They both have an x in common, but this one does not. So the greatest common factor is just 3. So let's pull out a 3. You should be able to divide these in your head, but if not, I'm going to do it over here just as a side note so you can see what I'm doing. We are dividing each term by 3. 3 goes into 3 one time and just leaves x squared. 3 goes into 24 8 times and leaves x. 3 goes into 45 15 times. So this is my factor that I have, and that's what I'm looking for. Now that I've taken out the greatest common factor, remember the next step was to check and see if it was a difference of squares. Well, obviously this is not two terms, there's not a minus sign in there, and these are not perfect squares, so it's not a difference of squares. Then the next thing is to look for target product, target sum, so that we can do grouping. The target product of these of A and C is 1 and 15. The target sum is 8. So I need numbers that multiply together to give me 15, but combine to give me 8. So the factors that multiply together to give me 15, but combine to give me 8, are going to be 3 and 5. So I need to rewrite my problem, but this time, instead of 8x, I will replace 8x with 3x plus 5x. I haven't changed the problem. All I've done was rewrite 8x to be 3x plus 5x. Now let's factor by grouping. Now remember, 3 is part of my answer, so I'm just going to move it down here. In the first grouping, I'm just going to put in x squared plus 3x plus 5x plus 15. Take out the greatest common factor in the first term, and that would be an x. That leaves me with x plus 3. In the second term, the greatest common factor is a 5. That leaves me x plus 3. The x plus 3 is in common with both of these terms, so x plus 3 is one of my factors times what's left over is x plus 5.